All right, Algebra 1B students, welcome to part 2 of lesson 7-8, a little more about geometric sequences. Just as a reminder, a geometric sequence from our last video is a sequence of numbers where the ratio of any term to the next one or to the one before it is the same. So in the last video we looked at what is a geometric sequence. How do we find them? How do we define them? And now we're going to look at how do we write a formula for them. All right. So we have two different formulas which you can find in this key concept box on page 467. It just talks a little bit about our starting value of A, right? Initial amount. We've been talking about that for a while. And now they're going to call the common ratio R. R for ratio. And that is just the number that you have to multiply by to get to the next term. All right? So, for example, in the sequence 2, 4, 8, 16, and so on, our initial value or our starting value would be 2. That's our A value. And our common ratio is, well, 2 times 2 would get me to 4. 4 times 2 would get me to 8. 8 times 2 would get me to 16. So both of these values would actually be 2. Starting value of 2, common ratio of 2 as well. Now, the two formulas that we can write for any geometric sequence, one is called a recursive formula or recursive definition for a sequence. All right? And that one has two parts. So you have to tell me two things every time you write a recursive definition for a geometric sequence. Right? You have to tell me, where do you start? What is your starting value? Okay? And then you also have to tell me, to get to the next value, to the next term of your sequence, you have to tell me what you do here as well. Okay? So A sub n just means the nth term in line. So first, second, third, nth term, whatever one you want. And it is related to the one before A sub n minus 1 times some common ratio, right? Because we know that to go from one to the next, we multiply by this ratio. Okay? So two things to tell me in a recursive definition. One is, what are you starting with? The second, use this kind of formula here to say, how do you go to the next term from the one that you have now? An explicit definition is just one formula that you can use to find whatever term you want in the sequence by plugging in a certain number for n. So let's say I wanted the 7th term of the sequence, 7th in line. You just put 7 in where the n is right there, and then you have the 7th term of your sequence. So this is just a single formula. It just says A sub n, which we would leave as a variable, whatever term it is that you want, is your starting value times your common ratio to the power n minus 1. So if you want the 7th term, that would be to the 6th power. Because to get to the 7th term, you have to multiply 6 times. Okay? Start here, you have to multiply 6 times to get from the first term to the 7th term. All right? So why do we need two different definitions? That's a great question. Thank you for asking. One, the recursive definition helps go from one term to the next. If you know one term, you can very easily find the next one using that recursive definition. So we go from one to the next. An explicit definition allows you to find the 7th term right now, or you can find the 17th term right now, or you can find the 117th term right now, or you can find whatever term it is that you want. Okay? So every geometric sequence has a starting value and a common ratio. Every single one. The starting value and the common ratio define a unique geometric sequence. You can never have two different sequences with the same formulas or definitions. All right? Can never happen. Now, our job in our practice problems is going to be creating these formulas given a certain geometric sequence. So, for example, let's look at this sequence right here. 7, 21, 63, 189, and so on and so on and so on. Okay? We know that our starting value is just this first term right here. Starting value is 7. And our common ratio, if we're not sure how to find it, remember that we can divide backwards from here back to here, here back to here, or here back to here. We can always divide backwards. And that's what your book has done. 21 divided by 7 gives us a common ratio of 3. So my A1 value, A1 meaning the first term where I start, is 7. And my common ratio, or my R value, is 3. Okay? So here's what we need to fill in on our explicit and recursive formulas or definitions. Okay? We need to fill in our A1 value, meaning our starting point, and our R value, wherever we see them in our formulas. Okay? So for our recursive definition, we have to say first, what is my A1 value? Okay, so we just say here, A1 equals 7. That's easy enough. That's just what your A1 value is. Okay? And then to go from one term to the next term, we just have to say what should we multiply by, and that, of course, is our R value, or our common ratio. So we know that our starting term here, A1 equals 7, and to get to some term, all we need to do is take the term before and multiply by 3. Okay? So A sub n, meaning whatever term you want to find, if you know the one before it, A sub n minus 1, you just times that by 3, and you found that term. Okay, so these two things together will tell me that whole sequence. Let me show you how that would work. If I wanted to write this sequence from this recursive formula, all I have to do is say, okay, A1, my starting value is 7. That's my first term. Now, if I want the second term, A sub 2, well, that equals A sub 1, right? 2 minus 1 is 1, times by 3. I already know A sub 1 is 7, so 7 times 3 gives me 21. Right? And now next term I could times by 3 again. 21 times 3 is 63. Times by 3 again. 63 times 3 is 189. All right? So that's a recursive formula. You tell me two things. What is the first value? What do you have to multiply by to get to the next term? Okay. Now let's look at our explicit formula, where we can put in whatever n we want and get it out without needing to worry about what comes exactly before it. Okay? So here in green is my definition, or my formula for explicit formulas. A sub n is equal to A sub 1, which is my starting value, times R to the power n minus 1. Right? Now again, the only two things we need to put in here are our A1 value and our R value. So A sub n, instead of equaling A1, I'm going to say that equals 7 times, instead of my R value, I'm going to say my R value is 3. And I'm still raising that to the power n minus 1. So my explicit formula is right here. Okay. A sub n equals 7 times 3 to the power n minus 1. So if I wanted, say, the 8th term of that sequence, 8th term, I would do 7 times 3 to the 8 minus 1, which is 7th power. 7 times 3 to the 7th power. Do that on your calculator to find out what that is. I'm not going to take the time to do it now. But that's how you would find the 8th term. Just put the 8 in where n is right there. Okay? If you have questions about whatever I just did, either the recursive or explicit formula, go back and rewatch some or make a note to ask me in class tomorrow. But I do want you to then do letter A and letter B, finding me two different formulas for each one, recursive and explicit. All right, now please be aware, over here, my R value is going to be a fraction because my numbers are getting smaller and smaller and smaller. I'm cutting them in half each time, so I'm going to say 1/2, or you can say 0.5 would be fine as well. Okay? So write a recursive and explicit formula for each one of these two sequences, and then come back and we will look at one more example of how we can use these formulas. Okay? So pause the video, take a look at A and B, then come back and we will look at some more examples. All right. Let's look at this type of problem, which is another common problem that you will see in your practice problem set. It says write a recursive formula and an explicit formula for each sequence. That's exactly what we just did in the last example, but now they also want us to add in here finding the eighth term. Okay? So now we're actually going to do this together. So letter A, let's do that one together, and then I will let you do letter B on your own. Okay? So letter A, I'm going to start by writing a recursive formula. Recursive. Now, I know I have to tell two things when I write a recursive formula. One of them is my starting value. Well, I know that my A1 value is 14. Easy enough. Okay? Now, what I don't know yet is my common ratio. Okay, so I need to figure out what is my common ratio there, and I will be able to then write the rest of my recursive definition. So if I want to find my common ratio, I just need to take two of my numbers here and divide them backwards, right to left. So I'm going to use the small numbers because those should be the easiest for me. 84 divided by 14, and that R value is 6. Okay, we're timesing here by 6. So 84, if you want to check this on your calculator, divided by 14 is equal to 6. So my R value equals 6. So what that means is to go from one term to the next, I need to multiply by 6. So I know that if I want to find some term, like a sub n, that's a semicolon there, by the way, a sub n is equal to the term that comes right before it, which we call a sub n minus 1, times by my R value times by 6. Okay, so if I know a term before, and I want to find a certain term, I just take the term before it and times by 6. So there is my recursive formula. I am all done with that. And now I will write, again for letter A, an explicit formula. Explicit formula. Remember that one has the general form a sub n equals a sub 1 times my R value to the n minus 1. Okay. I already know my A1 value. It's here. It's 14. So I'm going to say a sub n equals 14 times my R value, which is 6 up here, 6 to the power n minus 1. And now I can put in whatever value I want for n, and this formula here will spit out for me that term of my sequence. Right? So there's my two formulas, my two definitions, and you can use either one you want to find the eighth term of the sequence or whatever term it asks for. But usually it's going to be easier to use the explicit formula in our calculator. Okay? So if I want to find the 8th term of this sequence, 8th term, in order to find the 8th term, I'm just going to put 8 in for n in my explicit formula, because I find explicit formulas to be much easier to deal with in terms of finding a specific term number. So I'm going to use explicit formula. Now, I know that a sub 8, meaning my 8th term of the sequence, equals 14 times 6 to the 8th minus 1 power. All I did here was take both of my n's, both of these n's here, that one and that one, and I turned them into 8s. All right? Now I'm going to simplify. This is equal to 14 times 6 to the 7th power. Right? And if we do that on our calculator, 6 to the 7th power times that by 14, I get a very, very large number. A sub 8 is equal to 3,919,104. That is the 8th term of that sequence. By multiplying by 6, 7 times to get my 8th term, I end up at 3,919,104. All right? That's all they asked me to do. I have written 2 equations, here and here, and I have found for them the 8th term. That's right here. All right? Now, I would like you to do the same thing for letter B, for this formula here. Again, your R value is going to be something less than 1. Again, we are cutting in half every time here. Okay? So again, our R value is 1/2 or 0.5. Okay. So write me 2 formulas, please, and use one of them to find the 8th term. When you're done with that, you are all prepared for your practice problem set. So that's all I have for you right now. Any questions, please make a note to ask me in class tomorrow. Otherwise, have a great night.